So dimensional analysis have boundaries. One of it is that, you see, yesterday we derived the dimensions of speed and velocity. The dimension of speed is, what's the dimension of speed? Anybody?
LT minus 1.
Good. LT minus 1. And then that we also derive the dimension of velocity. And what's the dimension of velocity?
Please.
T
LT
minus 1.
Good. LT
minus 1.
minus 1. Meaning the two quantities have the same dimensions. Dimension analysis does not give any information of these two quantities as to whether one is a scalar and one is a vector. No, all that we know is that the dimension is this. So it does not give further information about whether the quantity is a scalar or vector. And so that becomes a limitation for dimensional analysis. So that's one of the limitations. Please put the information down. It does not produce any information as to whether the quantity is scalar or vector. 2, dimensional analysis does not give any information on dimensionless constants. It doesn't give any information on dimensionless constants. That is also another limitation. The third limitation is that,
please, the second one.
the second one is that it does not give any information about dimensionless constants. Constants without dimensions. It doesn't give any further information about it. Farida, your hand is up.
Please repeat the first point for me.
The first limitation is that it does not give any information on the quantity as to whether it is a scalar quantity or a vector quantity. And so it's a limitation. And the second one, I said it does not give any information on dimensionless constants. 3, if the relationship between a physical quantity is more than, or if the quantity depends on more than 3 physical quantities. If the physical quantity, okay, depends on more than 3 physical quantities, we cannot derive a relationship between them. If the physical quantity depends on more than 3 other physical quantities, equation or relation connecting them cannot be derived. You see, yesterday's assignment, I gave you, I think, T relates to the force, and I think it's rather length, height, h, and acceleration due to gravity. And you were with exponential, unknown exponential variables, and you were asked to determine. Here, what I'm saying is that if the relationship between perhaps time and the other quantities are more than 3, meaning 4 and above, we cannot derive a relationship between this quantity T and them. So it is applicable to 2 and 3. Anything beyond 3 cannot be determined, and that is a limitation. Class, I hope you are following.
Yes, sir.
Yes, sir.
Yes, sir.
Now, if the
Yes,
relation,
sir.
the fourth point is that if the relationship between quantity, physical quantities, is expressed in logarithm, sine, cosine, tan, we cannot derive an equation for it. So it is not applicable to logarithmic trigonometric equations. Dimensional analysis does not apply to logarithmic trigonometric equations. Maxwell.
Sir, please, the fourth one again.
Dimensional analysis does not apply to equations involving logarithm, log, and trigonometry. Trigonometry, I'm talking about sine, cosine, and tangent, the basic trigonometries. So if the equation between physical quantities is either logarithmic or trigonometric equation, we cannot apply dimensional analysis to them. So these are the 4 main limitations of dimensional analysis. So if you are asked about limitations of dimensional analysis, ladies and gentlemen, these are the 4 main limitations. Let me quickly drop attendance for today and then we continue, okay? So just give me a minute to do that quickly. Darius, your hand is up. What is your secret?
So I was just asking for you to repeat the fourth one for me.
The fourth one says that dimensional analysis is not applicable to trigonometric and logarithmic equations. Meaning if the equation is trigonometric or logarithm, we cannot apply dimension analysis in finding out any information about it. I want to quickly drop attendance, so give me a minute. All right. Having dropped the attendance, I think we can now start. All right. So let us also look at a question today, and then we can continue from where we go to. I've just dropped a question on a page, and to help us understand some basics in physics, I want us to quickly look at it. Look at the question. As for the dimensional analysis question, you solve it. Question 2, please, are we all there? Question 2, section B, are we there? Open to the question on the page.
Yes, please.
Okay.
Yes, please.
Some of them will just skip them. We will not spend time to discuss. 1A, define physical quantity. B, show how the unit of force, Newton, is derived from base unit. That is also easy. C, explain derived unit with calculations. Show how the unit of force, into bracket Newton, is derived from base unit. And calculate the weight of 5 kilogram mass on Earth with acceleration due to gravity of 9.8 meter per second squared, and on Moon, where G is equal to 1.6. This is also a simple question. 2, explain dimensional analysis and its uses. We have gone past that. Then check the dimensional consistency of V squared is equal to U squared plus 2AS. And then T is equal to 2 pi times square root of L over G. And then F is equal to mv squared over R. These are simple questions. We are to check the dimensional consistency or correctness or validity of the 3 given equations. And please, I've sent the question on the page. I want you to, at your free time, attempt question 2I to III. Solve it and then forward it to me for marking. It is not an assignment, but at your free time, I want you to do that exercise for yourself and for myself. Class, are we okay?
Yes, sir.
Whoever makes
Yes,
time to
sir.
do it, I'll make time, equally
sir.
make time, and then mark it for you. All right.
Yes, sir.
Okay, sir.
Then B is also a simple question. Use dimension analysis to derive a formula. The period capital T of a simple pendulum may depend on the length, mass, blah, blah. Is simple question. Okay. All right. Question 3. A boat sails 8 kilometers east. A boat sails 8 kilometers east and then 6 kilometers north. I. Calculate the straight line distance from starting point. Class, I'll give you 3 minutes to answer this question. So listen to it attentively. A boat, yes, Adisco is your question, don't worry. A boat sails 8 kilometers east. It sails 8 kilometers east and 6 kilometers north. Imam, mute yourself. Imam, and 8 kilometers, 6 kilometers north. The question is that calculate the straight line distance from the starting point. Can we try this in 3 minutes?
Yes, your mic.
Let's try this in 3 minutes. Start work.
Sir, please, I'm done.
Okay. Isabella, you're also done.
Yes, please.
Sir, please, I'm down too.
Okay. So, Isabella, what's your answer?
10 kilometers.
10 kilometers. I have Pascaline.
14 kilometers.
Dennis.
Sir, please, 10 kilometers.
10 kilometers. Okay. Please, let's solve it. Then, okay, let me give you the other question. Let me give you the other question. The other question says that calculate the bearing from the starting point. Calculate the bearing from the starting point. So let's quickly add the bearing question. Calculate the bearing from starting point.
Sir, I got 53.13 degrees.
I express your answer to the nearest degree. To the nearest degree.
53 degrees.
Okay. So somebody got 53. Mommy, we are solving a question, okay? It's just, we are solving a question which I just dropped on the page. I don't know if you are on the page. Are you? Mommy, yeah?
Yes, please. I'm on the page.
And so we are solving the question 3 of the question I dropped on the page. Okay.
Yes, please.
I say, Papa Kujo. I say, Papa Kujo, what's your answer? Okay, then let's look at it. Class, let's quickly look at it and then move on. So here, to be able to answer this question, you must draw it. Represent the information given to you on a diagram. We are told a boat sails 8 kilometers due east. So I sketch a cardinal point. Of course, this is my north. The south will be here, west, and then east. And we are told that a boat sails 8 kilometers from a starting point. The origin is the starting point, due east or in a direction of east. So let's assume that the 8-kilometer length or distance or displacement ends here. So this is a displacement of 8 kilometers due east. Then 6 kilometers due north. It's then sails 6 kilometers due north. So from where the initial displacement ended to its current position, this is the current position of the boat. The distance is 6 kilometers. Now what's the question? The straight line distance from the starting point. So this is the current location of the boat. This is its starting point. So calculate that straight line distance from the starting point. This is it. So that becomes the resultant of the displacement of the boat. Now, west-east is perpendicular to south-north. And so it forms a right angle triangle. So to be able to find this straight line, we need to use Pythagoras theorem because it creates a certain right angle triangle. Class, I hope we are all following.
Yes, please.
So let's indicate the origin as O. Abbas Farida. Farida.
Yeah.
I'm listening.
Yeah, but I don't understand. I didn't study this in school.
Okay. We would go through vectors, okay? We'll do vectors, so we'll come back to it where we'll start the very foundations, okay? Today we are just using the concept to answer your question. Daniel, are you on the same wavelength?
Sir, please,
Daniel,
yes.
okay, you don't
Sir.
worry. We'll address it, so don't worry, okay?
Okay, sir.
So the straight line distance will be OB squared by Pythagoras theorem. OB squared must be equal to OA squared plus AB squared. Those of you who are using my board, please don't share it with me. OB is what we are looking for. So OB squared is equal to OA is 8. 8 squared plus AB 6. So we have, what is 8 squared? What is 8 squared? 64.
64.
Plus 6 squared, which is 36. When we sum this up, we have 100. Must J leave my board alone? When we sum it up, we have 100. So OB squared is this. Therefore, OB will be equal to the square root of 100, which is 10 kilometers. So that's the straight line distance from the starting point will be equal to 10 centimeters. So those of you who mentioned 10 centimeters, you can be smiling. You can start smiling. Okay. Then the bearing. The bearing. Bearing is direction, and direction can be angle. Okay. So what is the bearing? If I am here, I'm on the x-axis or east-west axis. If I want to get the direction of the boat, okay, through what angle from the west-east axis do I turn? So it is this angle. You must turn. The displacement started from the x-axis. So if you turn through this angle, you get the direction or the bearing of the boat. So if you want to, from the starting point, follow it, then you have to turn through the angle and move that distance, and you get to the current position of the boat. So that is the bearing. Let's represent this by an angle theta. And once we have all the three parts, we have the adjacent to the angle, opposite, and then the hypotenuse. We can use any of the trig ratios to find it. Okay, so if we use tan theta would give us the opposite, which is 6, the adjacent, which is 8. This is the same as 3 on 4, isn't it?
Yes, sir.
So theta,
Yes, sir.
therefore, will be equal to the tan inverse of 3 on 4. And plus, what is the tan inverse of 3 over 4?
400.
The tan inverse of, not the inverse, the tan inverse. Tan inverse. So you press on your calculator,
36.8.
you press, come again.
36.86.
Please, it will be 36.86.
Give it to me to the nearest degree. The nearest degree.
36.7 degree.
So 37.
Oh, yeah.
Let's also use sine theta. What will be sine theta? Sine is opposite over hypotenuse. So that will be 6 on 10, isn't it?
Yes.
So theta is equal to the sine inverse of 0.6. What is the sine inverse of 0.6?
36.8.
Approximately 37. Correct?
That's
Okay, so all that I'm saying is that once we have all the size, we can use any of these three ratios. Please help me use cos theta and then give me the value of theta. Cos theta and tell me the value of the angle theta. Who has finished?
sir, please. 36.8
So to the nearest degree, 37.
37
37
Okay,
37
so good.
degrees.
So it means that if we are on the west-east axis, to get the bearing of the boat, we must turn through an angle of 37. However, we can also be on the north-south axis and also get the bearing of the boat. So if somebody is on the north-south axis, okay, through what angle
Okay.
must the person turn to get the direction of the boat? I'm asking a question. If the person is on the north, south, or the vertical axis,
Yeah.
hello,
53
that must be 53. So the bearing can either be 37 degree north of east or 53 degree east of north. These are all the bearings, the possible bearings. Either you turn through 37 degree northeast or north of east. Okay, north of east. You stand at the east and turn to the north. Or 53 degree east of north. So these are the two possible bearings. Class, are we okay here?
Sir, please, yes.
All right.
Yes, sir.
The next question. So those of you who did not do it, do not worry. It will be fine. 100 Newton force is applied at 60 degree to the horizontal. Let me write the question. 100 Newton force. 100 Newton force is applied at 60 degree to the horizontal. To the horizontal. Calculate I, the horizontal component, and II, the vertical component. Then we'll come to the third question, I. What does this question say? We have a force of 100 Newton is applied at an angle to the horizontal. So why the horizontal? You see, whenever we are in trigonometry, we are drawing angles. There is always a reference line where measurement is taken. So if you are to use your protractor, which is like this, you make sure that the 0 point, the angle 0 will be on this line, isn't it?
Sir, please,
Your
yes.
0 will be, so it means your reference point of angular measurement is to the horizontal. If it is to the vertical, I will make sure that the 0 line, the 0 of the protractor will be on the vertical. And this is how you take your angular measurement. So 0 will be here, the 90 point will be here, and you will measure your angle. So this is the reason for giving you the horizontal, meaning this angle is measured from the horizontal. Okay. So once you understand that, let's continue. So to draw the point of exertion of the force, my angle 60 must be taken from the horizontal. So 60 degree, I'm just assuming that this is 60. So that is where the force would act. The force will be here. The magnitude of the force, we are told, is 100 Newton. So 100 Newton, acting at an angle of 60 degrees. Ladies and gentlemen, you see, whenever a force acts at an angle, the force, let me draw something to explain this concept. If I draw the vertical axis, this is an angle of 0. This is 90. What is this angle? 0, 90. What will be this angle?
180.
180. What will be this angle?
360.
This is
270.
270 degree. Then we come back to 360.
Yes.
Good. Now, whenever
270.
good, whenever a force acts on any of these angles, 0, 90, 180, 270, and 360, the force will not be divided into two components. The magnitude will be 1. So when it acts here, if 100 Newton force acts along an angle of 0 and 360, the magnitude will be 100 degree horizontal, vertical component will be 0. When it acts along the 90 positive y, the magnitude will be 100 vertical, 0 horizontal. When it acts along 180 degree, the component will be negative 100 Newton, 0 vertical. When it acts here, the component along the 270 angle will be negative 100, 0 horizontal. But whenever it acts in between the 4 quadrants, 1, 2, 3, 4, it will be divided into 2 components, vertical and then the horizontal. Are we okay?
No,
Yes, sir.
No,
So
please.
note that
No,
when the vector or when the force, don't worry, when the force acts along any of these axes, 1, 2, 3, let me use different color. 1, 2, 3, 4. The force or the vector will not be divided into components. But the moment it acts in between the quadrants, okay, any angle between this quadrant, this quadrant, this quadrant, and the fourth one, then the force or the vector quantity will be divided into vertical component and the horizontal component. And that is the case we have here. Okay. So once we are told that it acts at an angle of 60, then it means we'll have please mute yourself if you haven't muted. We'll have 8 vertical components. Emmanuel, F vertical, and we also have 8 horizontal component, F horizontal. Now what we have? We have the angle of inclination and we have the hypotenuse. So we have a kind of right angle triangle. The vertical is always perpendicular to the horizontal. So if I have the angle of inclination and the hypotenuse, and I want to find the vertical. Which appropriate trig ratio do I use? If I have the angle 60 and then the hypotenuse, and I'm looking for the vertical, which appropriate trig ratio do I use, class? Anybody to help?
So the same.
We'll use no. We will use not the sine rule, but which appropriate?
The
Which
cos
appropriate?
Cosine.
We'll use
the cos rule.
sine. No,
The
you are talking. No, it's not the cosine rule. Okay, let's use the basic trigonometries. So we'll use sine, the trig ratio sine. What is sine? Sine of an angle theta is equal to the opposite over the
hypotenuse.
Hypotenuse. Good. So what is the angle? The angle is 60. So sine 60 will be equal to the opposite, which we are looking for, and that is F vertical. That is what we are looking for. Divided by, what's the hypotenuse? What's the hypotenuse here?
100
Newton.
Newton.
100 Newton. Good. So let's make F vertical the subject. What will be F vertical? Amuzu.
Sir, please, you said you are looking for the opposite, which is F vertical.
Yes.
Yeah, please, that part isn't it the adjacent?
You see, look at the size of the right angle triangle. We are O, A, B, and this is the angle 60. Which of the side is opposite to the angle?
Sir, please, that side, the F.
AB, and that's what I've represented as FV. Are you okay?
Yes, sir.
There is another hand up. Samsung. Samsung, quick one.
Yeah. Sir,
What's the question?
please, sir. I thought you said we should make the FV the subject of the equation.
Yes, we are making FV the subject.
Okay.
So what will that be?
50 Newton.
So 100, you multiply through by 100, isn't it?
Yes. And since sine 60 degrees is equal to 0.5.
Sine 60 is equal to 0.866.
60 degrees.
Sine 60. 0.8.
The answer is
it's 86.6. Now it's rather the cos. The cos
60.
is
no, sir, sine is 86.6.
Hello, listen. I know what it. Cos is 0.866 root 3 on 2, isn't it? Cos 60. Sorry, sine 60.
Yes.
So the answer will be 86.6 Newton. So that will be the vertical component of this force 100. Okay. Then the horizontal component, which is FH. Of course, the appropriate trig ratio will be cos 60. Cos 60 degrees. And cos is adjacent FH over hypotenuse 100. Okay. Class, are we following?
Yes, sir.
Good. So help me find F horizontal. Help me find F horizontal.
Sir, please, the answer is
The answer is what?
50.
50 degrees. 50 Newton.
So,
The answer is 50. 50
so
Newton.
100, I get you, 100 cos 60 degree. And cos 60 is 0.5. So 50.0 Newton. So these are the vertical component and the horizontal component of the force. Now, Darius.
Sir,
Mhm.
please, when I put sign 60 on the calculator, I'm getting a different thing than what I'm seeing here.
I'm sure, you see, check on if your calculator's angular measurement is on degree. If it's not on degree, it will give you different answers. So on your calculator, you see D, R, or J. If it's not on D, you get different answers. Which one is displayed on your calculator?
Okay, sir, I've seen it. Please, thank you.
All right. Please, is there any other question? Okay,
No,
let's look
sir.
at the third III question. Calculate the resultant if another 80 Newton horizontal force is added. Listen to the question so attentively. Calculate resultant if another 80 Newton horizontal force is added. It is added to what? It's added to the first question where we had 100 Newton force being applied at 60 degrees to the horizontal. And so we are adding another 80 Newton force. So let's clear our board and then let's clear the vertical because we are done with that part. So originally, this is what we have. And we are adding another 80 Newton force. You see, no angle is this time around given. Okay? No angle is this time around given. Let me read your messages. Camilla, we will treat vectors. It's because we are starting this, we are applying this to solving a question. That is where we are not going through the basics. So we'll come to vectors, okay? Well, I'll go through the basics for you. Alvin, the same response to you, okay? Okay, so those of you who are not so clear, please relax. We'll treat vectors where we'll go through the basics of this concept. So relax. The boat will never leave you. Melissa.
Sir, please, which one is the resultant?
I'm coming. We are yet to add the 80 Newton force. So we'll talk about the resultant, okay? So let's add the 80 Newton force. You see, in the question given to us, no angle was given. We are only told that if another 80 Newton force is added, okay, if another 80 Newton force is added, a horizontal force is added. Once there is no angle given, it means that the angle it makes with that reference point where angular measurement is taken from is 0. And that reference point is the horizontal. So it makes an angle of 0 with the horizontal. The 80 Newton force must be parallel to the horizontal. Let me bolding the angle for you. So this is the 80 Newton force. Let's assume this is just the magnitude. So it ends here. This is the end. The magnitude is 80 Newton. No angle is given, meaning it makes an angle of 0 with the horizontal. Please, are we okay? Are we okay here?
Yes, sir. Yes.
No, sir.
No,
So
sir.
we are adding the the 80 Newton force. The question says that calculate the resultant if another 80 Newton horizontal force is added. So we are adding the 80 Newton force to already 100 Newton force, which acts at an angle of 60. But here, no angle is given, meaning the 80 Newton force makes an angle of 0 with the horizontal axis. That is why it is placed on the horizontal x. Okay. Now we are to determine the resultant. Let me create a scenario. When Alvin and Dennis push a car, for the car to move, will you guys be pushing oppositely or you push along one direction? Alvin, the question is to you. For the car to move, will you be pushing from opposite directions or you push along one direction? Obviously, you must push along one direction. So you combine your forces. When you want to combine forces, the forces must act along one direction. And so, supposing you applied 10 Newton force, Dennis applied 10 Newton and Alvin applied 10 Newton along one direction, the total force becomes 20 Newton. And the 20 Newton here is the resultant force. Please, class, are we okay?
Yes, sir.
So
Yes, sir.
how then do we define
Yes,
a
sir.
resultant force?
Sir.
Hello?
Hi.
Okay, so a resultant force is defined as a single force. Are you listening? A single force whose effect is equal to the combined effect of a number of forces in all directions. Listen to it again. A resultant force is a single force whose effect is equal to the combined effect of a number of forces in all directions. So Alvin is applying a force of 10 Newton on the car. Dennis is also applying a force of 10 Newton on the car. Because they are all acting along one direction, okay, the combined effect on the car or the result on the car is 10 plus 10. So the resultant force is 20 Newton, meaning that what this 20 Newton can do, what this singular force 20 Newton can do, both two 10 Newton forces can do the same thing. So it's a single force whose effect is equal to the combined effect of a number of forces in all directions. Pascaline, your hand was raised.
Please, it was a mistake.
Okay. Now, supposing these two forces, class, supposing these two forces were acting oppositely, this is in this direction, 10 Newton, and this is also in this direction. What will be the resultant force? Nana Kwabena,
Zero.
zero. Good, because the one due east is considered as positive 10. The one due west here is considered as negative 10. So if I add positive 10 and negative 10 together, they will nullify one another. So that is how to determine resultant force. Don't worry, vectors would help us understand. So we have this scenario. How do we determine the resultant force? We can do that by realigning the directions of the forces. Realigning the directions of the forces. Okay. So 10 Newton force is heading along this direction. 80 Newton force is also heading due east. Can you tell the exact direction or where both forces are going? You cannot unless you reorganize their directions. And how do you do that? You do that using equal vectors. Equal vectors. Vectors or forces are equal no matter their location if they have these properties. One, they have same magnitude. They have same magnitude and they are parallel to one another. Same magnitude, parallel to one another, and they have the same direction. So I'm going to create a twin brother or a clone of 100 Newton force. And its twin brother must have the same characteristics as the original 100 Newton. So it must have the same magnitude as this. So I carefully draw the magnitude. Okay, so from start to finish, if 100 is starting from this point and then it's ending here, a twin brother must also have the same magnitude. Secondly, it must also have the same direction as 100. So if it is this will also act here. So I can also call this as 100 Newton because they are equal vectors. I'm also going to draw the equal vector of the 80, and it must have the same magnitude and direction as the 80. So it will also start from here. Its magnitude must also be the same as this, meaning I have to extend the 100 Newton a little bit. Good. Look at the direction of this is due east. So this must also be due east. Once they have set common features, I can also call this as 80 Newton. They are twins. Now look at the direction. If 80 is going to this direction and 100 is here, then I can confidently say that they are all coming to this point. Isn't it?
Yes, sir.
If 80 is going here and 100 is also continuing from 80 in this direction, then I can say
Yes,
both
sir.
80 and 90 and
Yes, sir.
100 are
Yes,
coming to
sir.
this point. So the resultant, or the picture this as you want to come here. Somebody says move from here and then continue your journey from here. Okay, somebody can also tell you, oh, instead of going through that distance, why don't you start from here and then move along the diagonal? You get to the same destination. That shortest possible distance becomes the resultant force after realigning their directions. So this becomes the resultant. That is the combined effect of 80 and 100. Okay, so that is how to find the resultant force. You resolve the forces into a parallelogram. As I said, we will look at vectors, and please, those of you who are not so clear, you get the opportunity to understand better. So we have triangle OA, parallelogram OABC. Within this, let's consider triangle OBC. Now, when two lines are parallel, it means they have the same slope or gradient. So if this and this are parallel forces and they are equal, the angle between this, which is 60, we must have the same angle here, 60. So if this angle is 60, class, what will be this angle? If this is 60, what will be this angle?
120.
120.
120. That is when you subtract it from 180. Good. So considering triangle OBC, it doesn't look like a right angle triangle, does it?
No.
No, sir.
No. So we can use
No.
Good. We can use Pythagoras theorem. To solve this, we need to use the cosine rule. Cosine rule. Let's look at the cosine rule. What does the cosine rule say? The cosine rule says that if you have any triangle, whether right angle triangle, isosceles, scalene, equilateral, and then this has a side A, B, C. Let's assume that the interior angle of this, the side at the angle opposite to C, this is theta. And the angle opposite to the side B, this is alpha. And then the interior angle opposite to A is beta. If I want to find, supposing I want to determine the value of the side A, the cosine rule says that the square of the side I'm looking for A. So A squared is equal to the sum of the squares of the other two sides. So B squared plus C squared minus 2 times the product of B and C. So 2BC times the cosine of the angle opposite to the side A. And class, what is the angle opposite to the side A? What interior angle is opposite to A?
Beta. Angle
So
beta.
this is beta.
Beta.
Cosine rule is similar to Pythagoras theorem, but slight modification. Okay, so how do we determine the side B? Note that A will be equal to the square root of everything. B squared plus C squared minus 2BC times cos of beta. How do we determine the side B? Anybody to help? Anyone to help? We want to determine, write a formula to determine the side B. Okay, Kekeli.
B squared
B squared
Is equal to
you cannot go
A
ahead.
squared
A squared plus
A
C squared.
plus C
plus
squared
C squared.
A squared
minus A
plus C squared
Minus 2AC.
2AC
Minus cos of alpha.
And cos theta.
times cos. No, the angle opposite to B
What's
is
the name
what?
of the sign?
Alpha.
Alpha.
Alpha. It's minus cos of alpha.
Cos alpha.
Exactly. Therefore, B will be equal to the square root of all that you said. A squared plus C squared minus 2AC cos of alpha. Papa, Osai Papa Kojo. It's a mistake. How do we determine B? I want to determine or write an equation to determine C. So how do we, Elom?
Sir. Yes, sir. Sir, please,
C.
it will be, yes, please. C squared.
You can all join.
C squared.
C squared is equal to A squared
A
plus
squared
squared
plus
B
B squared
minus
minus
2A
2A
Two A what?
B
B
A B
cos cos theta
cos
theta.
theta.
Good. So let's go back to our diagram. You can now mute yourselves. You can now mute yourselves. Let's go back to our diagram. We want to find the resultant. Let me answer some people. Some people are saying the Zoom is not working. Oh. Today too, the Zoom is not working. Eh? Did you find difficulties in entering the class?
No,
No, sir. No, please.
Ask the person
No.
to open the door.
No, sir. No, sir.
No,
No, sir. No,
not
sir.
at all. No, sir.
No, sir.
It's okay. It's okay.
No, sir. No.
Mute yourselves. Okay, so we want to find this side OB. We want to find a side OB, which is the resultant. OB. Let's apply Pythagoras theorem. So OB squared, class. Let's all join forces. OB squared
Is equal to
is equal to. Let's use the letters first.
OC squared.
OC squared.
Plus
Plus
plus CB
CB squared.
minus
Minus
2OC
2OC CB
times CB cos
120 degree.
120 degree. Thank you. Okay, so in that case, start work. Help me calculate OB. We have values for OC. Class, mute yourselves now. Mute yourselves now. We have values for OC and then CB. Help me find the value of OB. Start work. Emmanuel, I'll answer your question. But have you figured it out, Emanuela? How we got 60? Have you figured that out? Emanuela. Okay.
Sir.
Have you understood how we got the 60?
No, please.
You see, this angle 60 was given to us. We were told that 100 Newton makes an angle of 60 degrees with the horizontal. So the west-east is the horizontal, same as the x-axis. So we were told that this 100 Newton force makes an angle of 60 degrees with the horizontal. So when we measured an angle of 60 from the horizontal to where 100 Newton force acts. So that's how come we got this angle. Are you okay?
So did you apply the same knowledge to get the 60 in the red mark?
Good. And then you see, when two lines are parallel, they have the same slope or gradient. Okay, so the angle between the horizontal and the 100 Newton force, this one and OA and CB are parallel equal forces. So once they are parallel, then they will have the same slope. So if the slope of this is 60 degrees, then certainly the slope of this must also be 60. That is why we have this 60 here as well. Ella, are you okay?
Yes, sir.
Thank you. I'm sure you are done.
Yes, sir.
Hello. Okay. Let me.
Sir, please, a question.
You have a question. Okay, go ahead.
Sir, please, if angle BOC 60 degrees and angle BC 120 degrees, then how can we find angle OB?
Come again. Hold on, please. Let me finish answering the question, then we continue. Come again with the question.
Sir, I said if angle BOC 60 degrees.
BOC, no, it's not angle BOC. It is the whole of this angle. The 60 degree, okay. You see, BOC, you are referring to this acute angle. That's not what I'm saying.
Okay, sir.
Okay. Any more question to answer? Okay, please, class, let me take the last attendance and then get back to you, okay? I beg you. When I forwarded the first one, a lot of you had not joined then. So later on, we'll be calculating that angle you asked. Please, Dennis and go leave my board alone, okay? Osai Kwajo, your hand is up. Ask your question. Osai Kwajo, Papa.
Done.
Okay. No, I'll solve it with you. So if you got it right, you mark yourself then. All right. Let's discuss. So OB squared, OCS 80, CB is 100, minus 2 times 80 times 100 times the cosine of 120 degree. What is 80 squared? Plus, what is 80 squared?
6,400.
6,400. 100 squared, 10,000, right?
Yes, sir.
Now, cos 120 is equal to negative cos 60.
0.5.
Which is half. Cos 120 is negative half. So we have 2 times 80 times 100 times minus half. Minus half because cos 120 is equal to negative this. So these two would cancel. So we'll have 16400, okay, plus 8,000. plus 8,000. And what is 16,400 plus 8,000?
24,400.
Come again.
24,400.
Therefore, OB would be equal to the square root of 24,400. What is the square root of 24,400?
156.2.
156.2. Oh, somebody earlier gave me such an answer, Newton. So this is the resultant force. Show by hands those of you who got this right. If you got it, let me see you. Oh, a lot of you got it right. Oh, okay, that's good to hear. That's good to hear. Hello.
Sir.
Pascaline.
Please, sir. Sir.
I'm listening.
Please, sir, I got it right. But my own, the way I solved it, that's not how you did yours.
How did you solve it?
Okay. I did it square root
coming. Square root
of 130 plus 86.6, whereby the 130 is the addition of 50 Newton and the horizontal force 80 Newton. So it is 130 plus 86.6 Newton.
Okay. Yeah, you can have alternative.
So
Pascal, you can have alternative ways in doing it. We can even use Pythagoras theorem to find out. But I think I need to teach you something before. So it's good you have an alternative approach to the same question. Okay. Moving forward, I'll give you more skills in scoring the same goals. Okay. All right. So
okay, sir.
Let's find the bearing of the resultant. Let's find the bearing or the direction of the resultant. And that's the question one of you asked. You see, if I'm over here, if I'm on the horizontal and I want to face the direction of the resultant, I need to turn through this angle. Okay, I need to turn through this angle. Will the angle be less than 60 or greater than 60? Looking at the diagram. Would the said angle be less than 60 or greater than 60? Yes, it's less than 60. Please, class, can you all see? Good.
Yes, sir.
So,
Yes.
we can find this angle using the sine rule. Sine rule. So, we earlier used the cosine rule. We are now applying we use the cosine rule and we want to use the sine rule as well. I'm coming. Let me answer somebody. Said his Zoom is not working. It's not easy. Hey, who is using my board? It's not easy. All right. So, what is the sine rule? The sine rule also says that if you have any triangle, let me sketch a triangle. So A, B, C. The interior angle of this theta, interior angle of this beta, interior angle of this alpha. Aingra, leave my board. The rule says that if you take the ratio of the size to the sine of its opposite interior angle. So ratio of the side A to the sine of its opposite interior angle, sine theta. This must give you a certain value, K, constant. If you take the ratio of this side B to the sine of its opposite interior angle to B over sine of alpha, it would give you the same constant. If you take the other remaining C over the sine of its opposite interior angle beta, it will also be equal to a constant. Please, constant are numerical values. They can be numbers. So supposing it's 2, this will also be 2. This will also be 2. In that case, we can then say that then A over sine theta is equal to B over sine alpha, and it is also equal to C over sine beta. Please note that it is also the same as sine theta over A, which is also equal to sine alpha over B, and it's also sine beta over C. This is the sine rule. Class, are we okay?
Yes, please. Yes, sir.
So let's quickly apply the sine rule to find our interior angle. So we are looking for alpha. Okay, so sine alpha, this angle, over what is the side opposite to sine alpha? What is the side opposite to this interior angle alpha? What force is
B.
side BC? Side
B.
BC.
Yes,
Is side BC,
Side
which is 100.
BC.
Good. Which is 100.
B.
Good. This must be equal to sine of 120 degree divided by the force opposite to what at the angle 120. What's the force opposite to it? That's a resultant.
Yes.
Resultant.
And when we calculated, we had 156.2, isn't it?
Yeah, it's
Good. So make sine alpha the subject, which will be when you cross multiply 100 times sine 120 divided by 156.2. Class, help me find alpha. Start with. Whilst I read your messages. Caleb, so you later on draw my attention to what you want me to repeat, okay? Caleb. So draw my attention to what you want me to repeat after solving this.
Sir,
Hello.
sir, please, I got 0.6.
Alpha. I mean alpha, not sine alpha. Osai
Please, I got 37 degrees.
Okay.
Sir,
Hello, more views.
I got 33.66.
To the nearest degree.
33.66 degrees.
So you are around 30, 33. It should be, I think it should be 37. We'll do it.
Yes,
We'll,
37. 37.
Okay, all right. It's unfortunate. Okay, so please, those of you who can use the Zoom properly, when we finish, can you help your colleagues for me? Ebenezer, for instance, is having that difficulty in using the Zoom. Okay, I think he tries it and is not responding. Please help yourselves after the class for me. Okay.
Okay,
all
sir.
right. So
Yes.
sine alpha, we have 100 times sine 120 is the same as sine 60. And sine 60 is 0.866 and coins. We are not interested in the coins. So this divided by 156.2. So we have 86.6 sine alpha is equal to 86.6 divided by 156.2. Please quickly give me this ratio. 86.6 divided by 156.2. 0.6. 0.6. Please do not express your decimal values to the nearest DP unless you are instructed. So give it to me in about 3 DP.
0.5544.
In 3 DPO.
Yeah, 0.554.
553.
4.
Okay. Therefore, alpha is equal to the sine inverse of 0.554. And what's the answer? It should be 37, isn't it? Did you get 37?
Yes, I got 33.641.
33.641.
33.
Yes, sir.
0.641.
Let me check what is possibly wrong.
Please, I also got the same thing.
33. Let me calculate it myself and see. So sine inverse of. So shift sine, then 0.554. 33.6. So approximately 34. Okay. Degree. So this is the bearing. This is the bearing or the direction of the resultant force. Please, is there any question? Is there any question? If you want me to explain certain things, please let me know. Okay, so I think we are okay. Now, class today, in fact, there is general light out in the whole of central region. So it's possible my device cannot last, especially my battery cannot last till the whole duration. So we'll continue when it goes off. That is the reason. Unfortunately, yesterday the same thing happened. That's why we ended the class so abruptly. Okay, so it's possible the same thing will happen. So when that happens, then I earlier informed you. Now, Kwabena Usu.
Sir, please, I wanted to ask, when will the recorded version be out?
Oh, by today it will be in. Okay.
Thank you.
I'll upload it on the page. So somebody is suggesting we use Google Meet instead of the Zoom. Zoom has a lot of advantages over the Google Meet.
I don't think you can record a meeting on Google Meet.
I will even respond to concerns after the meeting. So the next thing we'll be doing, we'll be looking at kinematics, motion, okay, or linear motion. Linear motion. Okay. Dennis, please mute yourself. Let me mute him before he does that to us all. Dennis. Okay. So motion. Class, what is motion? Or how do we understand the term motion? When do we say that a body is in motion? Mamiya.
Okay, so please, motion is the change in position of an object.
Hold on. Is it Mamiya or Wusu?
No, please.
Your sister?
No, please.
Hey, you have the same voice as one Mamiya in Gehe. Okay. Mamiya, go on. Are you also in Gehe?
Yes, please.
Then you are maybe coincidentally in the same dormitory with Mamiya. Okay, go ahead.
Please, motion is the change in position of an object over time relative to a reference point.
So, when do we say a body is in motion? When, what exactly happens? Mamiya, you see, my question is embedded in what you said. Define your motion again.
Please, motion is the change of position in an object over time relative to a point.
Okay, relative to a point of reference or a certain initial. Yes. Okay. So my question is, when do we say motion has taken place? When? Russell, your hand was raised earlier.
Okay. When a body changes its location.
Its location, break location further.
Its position.
Its position.
Yeah.
Yes. Yes. So, Kingsley, your hand is also up. What the hell are you? Go ahead if you want to say something with that.
It's when a body is no longer at rest.
Okay. Of course, even when we bring it to human situation or during everyday activity, you cannot claim to be in motion when you are still at the same place. Me, I'm gone. As for me, I'm gone, and you are at the same location. Okay, so the only situation where we say that a body is in motion is when there is a change in position of the body. Can a body be in motion when there is no change in the body's speed?
No.
Can a body be in motion, or can a body to be described to be in motion when there is no change in its speed or velocity?
No.
You have to explain, no. Can a body be described to be in motion when there is no change in the body's speed or velocity? Who is answering? Where are they? Jennifer, Annan.
Please, no. Like you have to be in motion. If you want to be in motion, you have to change your position over time.
Jennifer, for position, we've understood that. Okay, we are clear with position that before you can be in motion, your position must change. But my question is that can a body be described to be in motion when there's no change in its speed or velocity?
No, please.
Okay, more views. Elon.
Yes, sir. Sir,
Which
please.
is yes? Is it yes, sir?
Yes.
Calling your name or?
Sir, please. A body can be described to be in motion, even though it's not moving, because it can decide not to change.
Elon, I didn't say that. He said even though it's not moving. What I said is that can a body be said to be in motion when there is no change in the body's speed or velocity?
Yes, please.
Okay, then go ahead and explain.
Because maybe it can be moving at 60 kilometers per hour, but even though it's still on 60 kilometers per hour, it is moving. So we can describe it as it's in motion.
Okay. Kekeli wants to talk. There are four other. Okay, Kekeli, go ahead.
Please, I think yes, because maybe the body is moving in one direction at a constant speed.
That's what he also. Melchizedek.
So I think, yeah, the body can be in motion without changing.
Melchizedek, can you speak up?
So I think, yes, the body can be in motion without changing its velocity.
Okay, yes. So, in fact, Jennifer, yes, let me wrap. Or you want to contribute?
Yeah, please. I wanted to say that how can a body be in how can a body be in motion when what will show that its emotion is not available? Like speed will show that something is in motion, velocity will show that something is in motion. So how we know it's in motion if all these indicators are not there?
Okay, so anyway, let's give Jeremy the opportunity to also contribute. Jeremy.
So I think yes, because let's say a body is in motion. That body in motion is not speeding or slowing. It's in the constant speed. That shows that a body can be in motion when there is no acceleration.
All right. All right. It's getting interesting. Let me wrap it up, okay? In fact, it's unfortunate my battery isn't strong at the moment.
Sir.
So, hello.
Sir.
Yes.
Sir. Please,
Yes.
can you repeat?
Can a body be said to be in motion when there is no change in the body's speed? And the answer is yes. It is true. A body can be said to be in motion when there is no change in its speed. When the body moves at a constant velocity. Okay, let me give a practical situation. You see that long distance runner in your school, 5,000 meters. When the whistle or the gunshot goes and the event starts or the competition starts, good runners can maintain their speed from start to finish. So they are moving all right, but their speed is not changing. Sometimes we see others, the moment the whistle goes, top speed as if he's competing in 100 meters, thinking that is the way out. And then in no time you see the person at the corner. Such running means that the person started with a higher speed and then the speed change dropped. So he's not able to, he wasn't able to move at a constant speed. Okay, so a person can be moving all right, but the speed can be maintained. All right, so a body can be in motion yet move at a constant
You're going back.
velocity. And also, if the velocity is constant, it means the acceleration is also what? If the speed is constant, it means the acceleration is what? Let me hear from you. I'm hearing constant. I'm hearing zero.
Acceleration is constant. No, the
Constant.
acceleration is zero.
Okay.
The acceleration is zero.
Okay, so
Zero.
I'll answer, but in motions you understand a lot of this. Now, when velocity or speed is constant with respect to time, acceleration is not constant but is zero. Is that okay? So under motions, in fact, we'll be going through all this, and it's an exciting topic to learn under physics. Okay, so class, it's unfortunate. Okay, Bobby, if you have a question, your hand is up. We are wrapping up. If you have anything to ask, Bobby. All right, I think Bobby is not even aware that his hand is up. Isaac Wilson.
Sir, please, the question that you asked. So was the body already in motion and it was maintaining a constant speed?
Yes. You see, the point is that you cannot be stationary and then be claimed to be in motion. The first reference for indicator for determining whether a body is in motion is that the position must be changing. Okay, so if the position doesn't change, the body is not in motion. But you can be in motion, your position can be changing, but yet your velocity or speed can be constant. Are you okay? That's my question. Have I answered you? All right, so class.